everyone. I hope you all will be fine, safe and healthy at your home, and I hope you all will be enjoying your online classes. So let us start our today's session. In our today's session, we are going to start the study of chemical equilibrium. So as you all know that in the previous session, I have given few examples of different types of equilibrium conditions. Okay, so let us start the chemical equilibrium, what it is. So here, it is a state established in chemical reaction is called chemical equilibrium. Means suppose any chemical reaction is going on, means reactant is converting into the product, or maybe product will also convert into a reactant form, means the reaction is in the form of reversible. So means the rate of forward reaction that is equal to the rate of backward reaction. That is to be the condition of equilibrium. So here I have written there the few example. Heating effect on calcium carbonate and combination of hydrogen and iodine, that is forming hydrogen iodide. So see here the characteristic of equilibrium constant. Let us discuss about it, and after that we will find out what is the equilibrium constant. So at equilibrium, the concentration of each of the reactant and the product becomes constant. That we must know that. Okay, reactant and product concentration must be constant. It should not be changed. Next, the equilibrium is dynamic in the nature, means it should be continuously, means forward to backward, backward to forward. Now, catalyst does not also alter the state of equilibrium, means catalyst, normally you have studied that catalyst alter the rate of reaction, but it does not alter the state of equilibrium, means catalyst का कोई effect नहीं पड़ता on the state of equilibrium. And the second thing, delta G, means the Gibbs free energy change that is equal to 0, okay, in the condition of equilibrium, that I have taught in the terms of thermodynamics. Okay, now you see here the next point which we have to understand, that is the law of mass action or the chemical equilibrium. That is the rate at which a substance react is proportional to its active mass. Okay, so law of mass action is also known as the equilibrium equation. So here I am telling, suppose A plus B, they are reacting and they are forming the product. So in that condition, the rate R, that must be directly proportional to the molar concentration of A and the molar concentration of B. That we must know that bracket, that we have to call it molar concentration, and these two are the reactant. So the rate totally depends upon the molar concentration of reactant A and B. Suppose the equation, let us consider 2A plus B, and that is forming a product P. So in that condition, rate that is equal to molar concentration of A, that coefficient goes into the raised to the power, and that the molar concentration of B, that number goes into the power. If we remove the sign of proportionality, then we can give a constant R is equals to K, that is to be A square and into the molar concentration of B. In this way, we can find out the rate. Okay, and this was the law of mass action, means the rate is directly proportional to the molar concentration of reactant or the product. Okay, so now the next thing, law of chemical equilibrium and the equilibrium constant. Let us imagine the equation AA BB, and that is forming a product CC and DD. So suppose as we have to find out rate of forward reaction by applying the law of mass action is directly proportional to the molar concentration of A raised to the power A, and that becomes B raised to the power B. Okay, so if we remove the sign of proportionality, then we can give the constant R is equals to KF, that A raised to the power A, and that is to be B raised to the power B. So let us talk about that backward reaction. When the reaction will move in the backward direction, then this product will act as a reactant. So in that condition, you can write there rate of backward reaction, that is molar concentration of C raised to the power C, and that becomes D raised to the power D. So that RB, that is equal to KB, that you can write there C raised to the power C, and this is to be D raised to the power D. At equilibrium, that we must know that at the condition of equilibrium, so that you have to know that RF, that is equal to RB, that means rate of forward reaction that gets equal to the rate of backward reaction. So you can write there here KF a raised to the power a, that b raised to the power b, that is equal to kb. This is to be c raised to the power c, and this is to be d raised to the power d. So if we will write there kf upon kb, so that can be written here c raised to the power c, and this is to be d raised to the power d upon a raised to the power a upon b raised to the power b. So the whole term can be written as a kc, that is equal to c raised to the power c, this is d raised to the power d upon a raised to the power a and b raised to the power b. So this kc we have to call it, this is the equilibrium constant. This is equilibrium constant. Okay, so what the definition of equilibrium constant comes in front of us. This is the ratio of the product of the molar concentration of product raised to the power of their coefficient and the product of the molar concentration of reactant raised to the power of their coefficient, that is to be denoted as the equilibrium constant. So let us talk about some characteristics of equilibrium constant that I have written for you. The first, Kc is applicable only when concentration of reactant and product have attained equilibrium. So equilibrium constant is applicable only in the condition of equilibrium. Now Kc is independent of initial concentration of reactant and product, means it doesn't depend upon the concentration of reactant and product. Rate depends on the reactant and product concentration, but equilibrium constant does not depend upon the concentration of reactant and product. Next, it is to be of Kc changes with change in time temperature. As the temperature changes, equilibrium constant also changes. Now the next is to be there, if the reaction is reversed, the value of Kc is inversed. Suppose Kc is the equilibrium constant for forward reaction and you have to find out the equilibrium constant for backward reaction. So Kc dash, that will be the inverse of 1 upon Kc. Okay, simply you can say that Kc dash is inverse of Kc. Okay, now if the equation is divided by 2, suppose in any equation you are dividing by number 2, so new equilibrium constant Kc dash, that will be equal to under root Kc. Next, if the equation is multiplied by 2, so Kc dash, that will be Kc square. Okay, now if the equation is written in 2 steps, few equations you will study that will complete into more than 1 step. So in that condition, the constant product of all the constant, that is equal to the equilibrium constant, new equilibrium constant, that is Kc dash. Now the next is to be there, last one, there is no effect of a catalyst on the equilibrium constant, means catalyst does not leave any effect on the equilibrium constant. Okay, I hope you all have got it, what is equilibrium constant, how to find out, and what are its specific characteristics. That's all for today's session.